AI is transforming applications, but with innovation comes new risks. Enter Noma, the first application security platform built to secure the entire data and AI lifecycle. From your AI supply chain to models and runtime, Noma protects it all. With a single platform that integrates seamlessly across your data pipelines, Jupyter Notebooks, ML Ops tools, code, and application SDKs, Noma delivers full lifecycle visibility, security, and compliance. Start securing your data and AI lifecycle at securityweekly.com/Noma. Welcome back to Application Security Weekly. We just talked with Daniel Stenberg about the life of libcurl, making C code secure, and not saying yes to CVSS. I'm your host, Mike Shima. I'm here with Kalyani Pawar. Kalyani, there was we took a tour of Sweden last segment, and I wanted to throw out there, I love my synthwave. For those of you wanted some, in addition to ABBA, Covenant, and Roxette, throw in some Robert Parker as well. But of course, we are very happy that Daniel decided to go the route of coding rather than a musician, because there's a lot of insecure code out there, and there's a lot of coding decisions that people are making. And one of those in particular is Google. They're deciding, how am I setting this up? I'll just say it. Goodbye SMS, hello QR codes. Now for me, this feels like a very positive thing. This seems good, but I know there's a population of, especially of InfoSec folks out there, who aren't happy or are worried, or, to try not to put too many words in their mouth, think QR codes are very dangerous, kind of like UL, but the URL shorteners never were, or maybe they're the same. Help me out. What do you think about this? Let's talk through QR codes, Kalyani.
First of all, we had phishing, smishing, and we're going to go with
No, stupid names, please.
But okay, so yes, I would say yay for security, but then it also makes me think about user experience. Say, my grandma doesn't know how to use QR codes. And so, I mean, I really want her Google account to be safe, but I also want her to be able to log into it at the same time. And so, yeah, that's the only area of concern I have. But I'm super happy about yay for security. Yeah.
Yeah, and I'm very glad you brought that up, because I also will be like, I love passkeys. Let's have passkeys everywhere. But I have to be quick to acknowledge that the user experience of the authentication part can be very seamless, very easy. But the account recovery can start to worry people. You know, what if I lose my passkey? What if I lose my phone? Do I lose access to my email? And bringing up the user experience part of QR codes is important. For me, it does feel like point the camera, click on, the URL that shows up in yellow on an iOS device, that it seems straightforward. But I think if we have all the way to the callback, what's the classic 1990s paper, Why Johnny Can't Encrypt? GPG had a terrible user experience. And that is the lesson that hopefully after these decades that the security community embraces and adapts to. Get that good UX. So that'll be one of those things I'd say we'll revisit this in a couple months, just to see if QR codes somehow made phishing worse or scamming worse. I love simple terms. Or I think the one other thing I do want to highlight here is that Google did point out some financial impacts of SMS fraud, basically sort of call it denial of budget, if you will, of just generating SMS messages. And that actually has a pretty good quantifiable impact to people. It's kind of a reverse bug bounty, if you will. So I thought that was kind of cool. But we have a lot of things to chat about this week, so we can't spend all of our time on stupid alternative names for phishing. But I do want to set up some more things about threat modeling. So I had another article about VSCode. Here, Microsoft pulled a VSCode extension that had roughly 9 million installs. So this isn't something that was just, unpopular, collecting dust, nobody noticed, over security risks. And there's a bit of text, subtext, and context here. The text is what I just said. They Microsoft pulled an extension because it had some red flags, and to quote, had some unreasonable dependencies including a utility for running child processes. And if all you want to do is have a pretty looking IDE, you probably don't need that. The subtext is that there was a lot of drama from the extension owner who attempted to bypass the ban or recreated a replacement. But the context I wanted to hit on here, and here I'm curious about what your thoughts from a development perspective, Kalyani, is that, to quote from the maintainer, this dependency that was called out as a red flag had been there since 2016. So it's almost a decade. And that removing it was a quick 30-second fix. So apparently, here's a dependency that they didn't really need. It didn't have, removing it was super simple, didn't have any impact on the features or the utility of the extension. And here I'll have to make fun of NPM a little bit, why do so many NPM node systems have a ridiculous amount of dependencies? That feels like an anti-pattern to me.
I mean, sure, we're talking about NPM packages going wrong. That happens all the time, right? But, one thing that really stood out to me in all of this was it had, I think, 9 million pulls, you say? And then if the fix was so easy, and why don't we just start building things out where minimal dependencies are installed in the first place, more than whatever is required? If we started that from the first, that's the first line item. If we have that, we wouldn't ever have to be here where we're discarding an extension which people liked, was popular, was beautiful to use. And then now we have a maintainer fighting for their rights. So, yeah.
Fight for your right to party, the Beastie Boys would approve. But yes, I think part of the reason I was pulling out this, talking about the NPM and JavaScript, is that Java as a language, or ECMAScript, as the standard, has actually changed over time. And a lot of NPM modules, I think, were polyfills that were basically like, so many people out there aren't using auto-update browsers. We have a huge variety of browser populations. These days, for better or for perhaps mostly worse, we have a very small browser population. And auto-updates mean we have a very short long tail, if such a phrase can make sense, of different browser versions. So I feel like we need fewer of those polyfills. And to your point too, about do we need all these dependencies? The left pad is a good classic one to go to, that it was impacted a few 100,000, maybe a few million projects over literally 17-line file that just did a trivial function. So I'm struggling to be like, I just would love to see, maybe there's an LLM use here where an LLM could just say, you don't need these 20 dependencies. You could replace them with these 3 functions. And we've seen this too, as I continue my stream of thought, in Proximo, the group that was rewriting DNS, TLS, NTP, I think, into Rust. It was the DNS, I think, that they said, their first draft of the rewrite still had 100 or so crates and dependencies. The final draft got it down to low double digits, like I think just a dozen, or maybe it was only 8. So already, to your point, we've seen reducing dependencies as a great security approach. Now, I'm going to take a breath and jump to a couple more. This is why we don't have nice things. You had 2 articles, kind of supply chain related. Tell us about some malicious ML models.
I will. Continuing the spree from LLMs from last week, I did have an article about malicious ML models being uploaded to Hugging Face. So what's happening here is an attacker devises a malicious ML model, but they upload it in a 7Z format, which is where the Hugging Face scanners miss it, and then they don't detect that this is malicious enough. And so, friends, here is a classic way of defeating a scanner if it's not looking for the right extension. And so it also makes me think about, obviously, supply chain attacks. Like how, as say in a normal AppSec pre-LLM world, were we trusting all of the NPM packages that we installed? No. So why are we doing that? ML models? I just want an honest answer.
No, indeed. And that article I had about the VSCode extension, one of Microsoft's objections to it was that it had clearly obfuscated JavaScript, which, Chrome extensions, they don't want to see any obfuscated JavaScript. VS Code extensions, you just don't want to see that, because you want to be able to basically read what is this code that I'm loading into my IDE or my browser. And you're pointing out here the zip versus 7Z. That feels like such a classic, email security virus scanning where, it used to be that just zip a file or create a Google Doc or a PDF is the great way to bypass, the virus scanner because it's not even obfuscated. It's just in a different format that the scanner didn't bother to open up and peek into. But there's also a fun one. Now, there's some clouded judgment, the AMI name game gone wrong.
Yes.
Tell us more. Who am I?
Say you're a cloud engineer and you're trying to set up a new server on your AWS environment. You write a simple script to grab the Amazon machine image, the AMI, right? And it's a simple name. You give it a name, it fetches it, right? But imagine if there's two different AMIs, one the good one, the other the bad one, and the bad one is the latest one, and that's what we end up pulling. And so here we have a whole attack chain. Imagine lateral movement, imagine crypto miners, imagine the kind of possibilities on the Who Am I attack. And I think this research is by Datadog. So I really, I usually like their security researches. And so I picked up this one for this episode.
Oh, it's great, and it made me just as I saw the very title of it, made me think of the dependency confusion attack from researcher Alex Burson. And what I loved in this article that you pulled out is that it also explicitly acknowledges that prior work. And the dependency confusion is important to bring up because it's also just talking about what's the latest version of this dependency. Is it, and we can talk about dependency in general. We're talking about a pip, a gem, npm package, etc. And it's just a great example that here's an attack class. And now, as this article is pointing out, here's how this class is applied to EC2 instances and pulling down AMIs. And so it's not so much, do we just fix this on the npm platform or some other package repo or package management platform? How do we, any place we are pulling down version instances, what are principles to apply there? Now, one other thing, Kalyani, in the write-up for this, that I hope everyone goes and checks out our show notes all the time, you had a metaphor. And now I always have to jump on AppSec metaphors because sometimes they irk me. But having fun with this, I'll read what you wrote is that it's sort of like if you're trusting automation without verification, make a very good point, the cloud equivalent of leaving your door unlocked in a bad neighborhood. Now, for me, this dependency confusion feels a bit more like you actually live in a very nice neighborhood, but you're inviting people over and you're just emailing out RSVPs. And as long as somebody has that invitation, they're welcome to come in and join your party. The problem here is sort of like when you're addressing those invitations, you're sending them out and you're saying, "Dear Mike" or "current resident," and you haven't followed up that the person that you thought you wanted to invite over is not the person who lives there now, or somebody just pulled that invitation out of the mailbox and showed up. So this is also why I don't get invited to parties, because I talk about AppSec metaphors like this. So my apologies.
You wouldn't believe the number of weddings have crashed because of
the social engineering. So speaking of social engineering, this might have been this might have appealed to you. There were some North Korean hackers stole 1.5 billion from Bybit. Now, you probably, from crashing a couple weddings, got some free drinks and hopefully some really good canapes and whatnot. I don't know that you've got 1.5 billion from it because you're hosting a podcast and with me. But yeah, this one stood out as, okay, on the one hand, it's yet another crypto hack, yawn, just long sigh. But the mechanism and the technical aspects around this really stood out to me, and it grabbed your attention too. Let me throw over to you first about what appealed to you about this particular hack. Why did this catch your eye?
So, since we're talking about automation and everything, it feels like, as security folks, we spend so much of our time making processes better, making sure that the business logic is successful. But we don't often spend time thinking about user behavior or how humans are the human element of security, how humans themselves can be tricked. And so when I read this article, it made me think about they did have like in the traditional setting, they do have fraud detection and a human in loop, and there's different layers of verification. But I think when it's crypto, it's slightly a little different, right? And so, well, here you go, billions of dollars siphoned to North Korea.
It is. And what's interesting here is that I very much like that you're pointing out that the people aspect and the process aspect. This is a little bit of what we talked about last segment with Daniel as well, about the process of who's writing the code. Are they being coerced? Are they making mistakes? And those are very much independent of what you're writing in. Of course, the curl is in C. We were talking about that. Daniel had a wonderful Perl t-shirt on. For those of you who are watching the video, the back of it, by the way, good Easter egg. It was the classic Perl RSA encryption. But that's a fun aside. In this case, we're talking about JavaScript. And this JavaScript, what the attackers did was not just click on a link. They compromised, here's our supply chain again. They compromised a vendor to Bybit, and they changed the JavaScript that's being used for wallet manipulation to only trigger if Bybit is visiting it. And it created essentially an overlay that made it look like the Bybit admins are doing the right ceremony. And here I'm using this term ceremony because it comes from a fun Microsoft paper from early 2000s, I think, that's basically the idea that you can define a protocol for computers to use for network communications or for a process. And once you add people to it, you kind of have a protocol plus people is a ceremony. And you have a signing ceremony to say, our cold wallet does need to replenish our hot wallet, and the hot wallet shouldn't have all of our Bitcoin eggs in one basket because that's dangerous. But this UI change that the hackers did made it look like this ceremony, this process that they were going through, were doing the right things, when in fact, it was just using a smart contract to drain a whole bunch of F into the ether so that North Korea could go launder some more money. And there's just some really cool, there's some really cool technical techniques behind it. Also clearly something that was, call it long-term planning, possibly on the order of months in this case, but much more than just sending a QR code that has a malicious link inside it. One of the things that I wanted to talk about here too, and you've been very helpful in setting this up, Kalyani, is talking about process, talking about these types of consequential things, is threat modeling and what makes a good threat model. So I have, once again, I have to admit, another article out of the Trail of Bits blog. This is threat modeling the trail in capital letters of Bits Way. And that's the trail stands for Threat and Risk Analysis Informed Lifecycle, which is, I'm always a fan of acronyms, so that's pretty cool. I would have gone with maybe BITS and call it the Building InfoSec Threat Scenarios, but we'll see. We'll see if their marketing reaches out to me for that one. But Kalyani, this is talking about yet another approach to threat modeling in a way. But before we get into the details of this article, I want to ask you, in your mind, what makes a good threat model versus a bad threat model? If I just pitch it that way, what comes to mind for you?
When we're thinking about a bad threat model, I don't think it's useful to just think about let's use this library and then we can avoid all sorts of injection attacks. I don't think that's a useful use of everyone's time. But instead, a good threat model would be where we're able to identify business logic errors. And there's no core security when it comes to business logic, right? And that's just the human element, again, bringing it back here, the people part of the process also lies in a good threat model. And yeah, I think a successful threat model is when you can identify business logic errors way before they make its way to the code.
Yeah, and I like that the immediate response is that business logic, things that all scanners still struggle with. We as an industry haven't really successfully automated that to any degree of great confidence. Because for me, if someone's starting to talk about threat modeling and they say, what's your API? Where are the endpoints? How does this endpoint deal with cross-site scripting? How does this other endpoint deal with XSS? How does this other endpoint deal with it? How does this endpoint deal with SQL injection? The developer is going to fall asleep. Kalyani is going to fall asleep, and rightly so, because that is just the most boring thing to do and feels like such a waste of time. Instead, I love those questions that are more about how did you consider, or how are you dealing with the vuln class of cross-site scripting? And they answer hopefully something like, we use React. That, those easy types of short answers that point to some type of architecture approach, architecture solution. And I think that's what this Trail of Bits article is really trying to emphasize. They want the outcomes to be, what are you identifying as the design level weaknesses of this system, not where every little endpoint has a cross-site scripting problem in it.
I think I also want to add to that. It's if I were to give an example about what a good threat model is versus bad threat model. I remember this time back in school, we were trying to threat model a FedEx kind of delivery system.
Oh, cool.
And of course, we were talking about this is the login workflow and all of that, and we should be using whatever library to avoid these injection attacks and everything. But I remember I just suggest that how do we defend against things like explosives or things that are not supposed to be shipped in this delivery system? And I think threat model is useful if we can go behind those kind of errors.
That's a great setup, because I also one of the things I appreciated about this article is that it's talking about threat scenarios, kind of the classic case of what could go wrong, or what's the worst thing that can happen. And they do talk about threat actors, but they mostly just say they define it by role, or kind of what by their privileges. For example, local root, or a repository administrator, or just external attacker. To kind of riff off your FedEx example too, when I approach threat models, I prefer the simplicity of just, we need an actor who's doing this, but we don't focus on motivations. We focus more on their goals, meaning I want to send some explosives via a package, versus I am fill in the blank, because typically that blank of who the motivation is doesn't really matter. It could just be, as we've seen over 2 summers ago with social engineering attacks, you could be some teenagers hanging out in the United Kingdom, or you could be getting into Twitter or Slack, etc. Or you could be North Korea, a big well-funded APT going after Bybit. Who they are might influence techniques, but the motivations don't really matter as much as their goals. As I say that, is that something that makes sense to you, or how do you approach actors in threat modeling?
I mean, I don't think about motivation because it's a threat actor, and so it's always supposed to be on the negative side, right? Techniques, yes, I think I necessarily do not like to think about just rules, but like I said, when you sit for a threat model, just look at the diagram and then roll with it, rather than a restrictive technique approach.
Yes, and I think that's too what I liked about this trail. That yes, they did have to throw an acronym in there, but they didn't call out STRIDE or DREAD, which was even dead almost from the beginning, because those are really just terminology that can be helpful to prompt people. I do like that they reference Mozilla's rapid risk assessment, because that one, again, the RRA is nicely focused, that says, you know what, everyone's time is important. Maybe it takes 30, 45 minutes tops to have this conversation with your developers. And you're really just saying, what data do you have? What are the workflows, and what's the worst thing that could happen? And rather than going through, it's not really an OWASP top 10 checklist. Did you deal with cross-site scripting, SQL injection, IDOR? Do you have strong authentication? It's more of what happens if your authentication fails, or what happens if somebody gets into someone else's account? What could the consequences be? Do you have ways of detecting it? Do you have ways of recovering from that? That's what I love to focus on. And so that is more of just what I really wanted to drive home, hopefully for our audience. If they agree, if you don't, let us know. That for me, threat modeling is way more useful for all participants if you're touching on, as Kalyani said, business logic, rather than just repeating things that you could actually run a scanner to do. Now, Kalyani, we can talk about some other things, and so we're going to revisit threat modeling throughout the rest of the year through secure designs. But one of the things that threat modeling represents is called some maturity. And I don't know, maybe when you've worked with clearly small, startups, when do you first do a threat modeling with developers? Is there a certain point where you're like, oh yes, we're ready to have this conversation, or we're going to hold off for a while because we need to do something else first?
I mean, if the feature has to deal with any security concern, we have to threat model it right away, like in the requirements phase itself. But if we're talking blue button or red button, I don't think I'm going to be a useful addition to that conversation. But yeah, if the button has to do with login, call me.
There we go.
Yeah, and so that's how I think about threat model. And also another thing I like to think about is, threat modeling in its way in practice usually happens only in the beginning phases of SDLC and not much after, say, the form starts changing stages, right? I think that's an active problem that the whole community is trying to solve, where we just don't threat model once, but as often as we can. Yeah.
Yeah, and I think we've seen a couple examples where we've seen threat modeling exercises or major version changes within open source projects. Say we had to update our threat model. We had a little bit of that conversation when we talked about the OAuth 2.0 and the OAuth best practices RFC that came out a couple weeks ago. Is that best practices RFC was updating its threat model because they've seen how developers have chosen to use. We won't say misuse and use any judgment. It's just chosen to use OAuth for scenarios that weren't anticipated, and browsers have different security properties that weren't anticipated or thought of. So, yep, time to update our threat models. One of the other reasons I asked that question is that where we've been talking a lot about people and process, and OpenSSF has a new project called the Open Source Project Security Baseline. So here is something, again, that just kind of tracks, call it maturity or things to do within the maturity of an open source project. And this things to do is more in standards like the NIST CSF or the more specifically the Secure Software Development Framework or all these other external frameworks. That this is, if you've ever had to work with your compliance friends in compliance and you've ever seen a spreadsheet, it's sort of a crosswalk. It's just basically how do we map a whole bunch of things that are recommended for people to do into a smaller list. So I wanted to highlight this as one of those things that hopefully is helpful to demonstrate from that we as a project are doing something. It fills in, as they say, some gaps that the scorecard can't automatically figure out. And there's already a best practices badge that OpenSSF has. And this is maybe the sweet spot in between them, but I'd still say it's a self-attestment. And it's sort of, you just have to say that you're doing these processes and demonstrate how it's enforced. And it made me think of, as our discussion with Daniel, that they do just by nature over the years, they've evolved into, I think, essentially doing these types of OSPS baseline practices without calling them baseline practices or without calling any particular standards. So I don't know. Do you feel like filling out another, Excel spreadsheet as you're building code, Kalyani?
No.
No? Okay. All right. We better move on. There's another thing about very fair answer, and that's why I wanted to ask. So I did want to pull out another thing from from OpenSSF. This is their Alpha Omega, or the beginning to the end of securing the open source ecosystem. Now, this article is a bit older, it's from the end of January, but it's showing their investments into open source ecosystem. And I liked it because they're demonstrating some transparency, and they're responsible for staffing up security roles within a bunch of organizations. They call out Python, OpenJS, Ruby Gems, and a few others. They've also, for example, used this money to support Rust implementations of TLS and the AV1 codec. And we covered that codec a couple months ago too, talking about parsers are a great place to have memory safe code. So, but where I wanted to get this, and maybe your thoughts too on this, is that speaking of spreadsheets and corporate things, there's also OKRs, and they have a PDF here about OKRs, and one of them is one of their goals is the top 10,000 open source projects are free of critical security vulnerabilities. That seems like a great goal. If we put on our prediction hats or our process hats, how viable do you think this goal is? Or what are some strategies that you think or that you hope are coming to mind for them?
Well, okay, even before strategies, I'm thinking about do executives wake up in the morning and think, how can I improve security? Because if then they do, it's gonna make my life simpler. And so this is my dissatisfaction with OKRs. So like we need to find 60 vulnerabilities in the code base, and that means we're, I don't know, 60% more safer. I don't think so, because it depends. Is it like a, I don't care about this, I do other kind of a vulnerability, or is it like, let me see what the other user's PII is kind of vulnerability, right? And so I find it really hard to set our goals with a numerical OKR.
They are at least measurable in this case, because they're saying that we're going to focus on 10,000 projects, which probably 9,000 of those are just NPM packages. Sorry, NPM, I'm picking on you this week. But the other thing that is also mostly a quantifiable, but a little bit of a qualifier maybe to be fair, is, critical security vulns. And, we had that discussion about CVSS and context with Daniel last segment. So part of the reason I wanted to pull this out is that in the spirit of checking at the end of 2025, did we, as the industry, did we see any open source critical vulnerabilities in any of these projects? And if we didn't, because we were lucky, that's good. But if we didn't, because the OpenSSF encouraged more fuzzing or encouraged more ways of doing how they killed off a vuln class, that's what I would love to see and learn from, because there's no way that 10,000 projects are going to rewrite themselves into Rust, for example, nor should they. So that's where it's really interested, is how do you scale this up? Because as you said, I don't think anybody, even at Microsoft, who is taking security extra seriously in 2024 from Satya's email, they're probably waking up and being like, 10,000 projects, that's, we've got that. We've got 100,000 projects. We need to scale and do something different. So
Yeah.
those are my thoughts there. Yeah. So Kalyani, we've gone through a bunch of things. Our theme, hopefully this news segment, was to try and touch on threat modeling. And maybe we didn't go into threat modeling deep enough, but I'm curious, maybe as we wrap up here, if you've got one more bit of advice that either applies to one of the articles as an example that we covered here, or things that our listeners can think about for the future. What would you leave them with?
User behavior. I think I would definitely leave them with the human element that we've discussed a bunch of times in threat modeling. And it's harder when security is trying to compete with velocity. And so if we have useful threat modeling discussions focusing on those specific kinds of errors, rather than making sure we have the right requirements.txt file, I think it's a better discussion to have.
I love that. Save everybody time, use their time wisely. And hopefully, Kalyani, I've been using your time for this news segment wisely as well, because I want to say thank you for joining me once again.
It's always fun to be here.
Want to thank everyone else for joining us. Please do remember to subscribe, share us on the socials, check out the show notes. And speaking of a better future, check out Digital Dream by Lau. We'll see you next time on Application Security Weekly.